You're watching this. This is Mr. Robinson, and a quick review of graphing from slope-intercept form. Hopefully, this is a review. Hopefully, you kind of have this concept down. If not, well, here's a chance to get all the information you should need to graph a line that's in slope-intercept form. So slope-intercept form is y equals mx plus b. Note that occasionally, I'll cover this again, you're going to see this written also as y equals b plus mx. The key here is just recognizing where the x is at and then tying that to the slope. So in the equation y equals mx plus b, the slope of the line is represented by m. So m is just a placeholder for a number in the future. And the y-intercept is b. So b is the constant, or the term without a variable next to it. So just remember, those can be switched. Sometimes you'll see the y-intercept in front of this slope, but usually you're going to see it this way. All right, so we've worked with graphing. We've talked about slope. We've done all this a little bit. We talked about slope, dude. The idea of a positive and negative, a zero slope and an undefined slope. We've done all that, and we've worked a little bit with graphing, actually quite a bit. So here are the formal procedure on how you graph a line in slope-intercept form. The first thing I want you guys to note, if you're taking these notes at home, you're not doing them in class with us, what I have in bold, the bold black, is really what you need to be writing down. But the hints are also going to be helpful if you get stuck on a problem. So if you want to write those down, I'd encourage it. But what you really need is what's in bold there. Okay, so step one is identify the y-intercept, which is the b of the line. Place this point on the graph at the point 0b. So when we go over an example, I'll explain to you why that's always going to have an x value of 0. Okay, for equations like y equals 2x, where there's no b given, it will be 0. So if you don't see a constant in the equation, right? If you see y equals and then a number that's tied to a variable, the variable x, but you don't see a constant, that constant will be a 0. Just think about it. You can always add 0 to something. It doesn't change anything. All right, step two. After you've placed that y-intercept on the graph, you're going to use the slope to place additional points on the line. It is recommended that you put at least 3 points. Now, in some cases, you might only be able to get 2. You need to have at the bare minimum 2, but it's recommended you have at least 3. I always say the more the merrier. It makes it easier to make that line. Okay, your first thing here, if the slope is a fraction, the numerator, the number on the top, will tell you how far you are going up if it's positive or down if it's negative. The denominator will tell you how far you're going to the right. There are scenarios where you might have to work backwards. You just switch both of them. Okay, hint. If the slope is an integer, the run will always be 1. So an integer is a number, a negative, positive or negative, quote-unquote, whole number. Negative numbers aren't technically whole numbers, but that's fine. So if it's a number that's not a fraction, you can turn that integer into a fraction by placing a 1 under it. So, for example, let's say we have the slope. Slope is 4. We could just say that's the same as 4 over 1 to indicate we're going up 4, right 1. Let's say if the slope is negative 4, we could say that is negative 4 over 1, which means we're going down 1, down 4, right 1. So a couple hints to keep in mind. When you're done, make a line that connects the dots and that goes completely across the coordinate plane. A lot of students will make these little fragments of lines. Make the whole line. Just make it cover the whole graph. Especially if you're doing this on paper, you can find a straight edge. It doesn't have to be a ruler. It can be a book. I've seen kids use pens. I've seen kids use phones. I mean, anything that's a straight edge, a piece of wood, doesn't really matter. A cardboard box, you get the idea. All right, let's look at some examples here. So if we're looking at example y equals 1/3 x minus 2, I want to graph that line and clearly mark 3 points on the line. Before I start, I'm just going to go ahead and quickly identify the slope and the y-intercept. So my slope here is 1 over 3. I know that because it's next to the x, and my y-intercept is negative 2. So first thing I'm going to do is place that negative 2 on the graph. So I'm going to place that negative 2 here. Then I'm going to use the slope to place additional points. In this case, we're going up 1, right 3. I know it's up because the slope is a positive number. So I'm going to go up 1, right 3, up 1, right 3, up 1, right 3. So I'm doing this quickly, but what I'm doing is counting up 1, and then up 1, then right 1, 2, 1, 2, 3, up 1, then counting over 1, 2, 3, up 1, 1, 2, 3. Okay, after I have that done, I'm going to go ahead and insert my line. All right, so And I'll do mine digitally, and I'll try to stretch it out over the whole graph. So there's that first line. You notice it has a puff, puff, positive slope, and it's going up 1, right 3, and it starts at -2. All right, there's our first example. Let's scroll down to the next one. Okay, in this one, you'll notice that the y-intercept and the slope are switched. So in this case, my y-intercept is actually in front of the slope. I know that's my y-intercept because it does not have an x next to it, right? And my slope in this case is -2, so I got to include that sign, right? So remember, we can turn that into a fraction by just saying -2/1. This means I'm going down 2, right 1. We're starting at 6, so I'm going to go ahead and put my first dot at 6. Okay, and then we're going to go down 2. We're going to go down 2, right 1. 1, 2, right 1. 2, right 1. 2, right 1. Repeat the pattern until I'm at the bottom of the graph there. I have them all spread out. Then I'm going to go ahead and insert my line like I did last time. So I have a relatively decent graphing tool to use. Unfortunately for you guys, we use Jamboard where you have to print it, just because, quite frankly, nothing else really works that great. That's for free. Anywho, this is a nice negative slope. I know that because it's -2. I'm starting at 6 and I'm going down to right 1. All the information you need is in the equation itself. All right, one more example. So this equation right here is y equals -7/2 x plus 1. You'll notice we have the slope. The slope in this case is -7/2. So if you have a negative fraction like that, I want you to think of it like this. So just move that negative sign to the top. That means we're going down 7, right 2. And my y-intercept is 1. Okay, so I know that's my y-intercept because it does not have an x next to it. The first thing I'm going to do is put a 1 on the graph. Then I'm going to go down 7. So I'm going to count down 1, 2, 3, 4, 5, 6, 7. I'm going to go right 2. 1, 2. All right, now I told you might have to go the opposite direction here. If I want to get 3 points on this graph, I can't go down any further to the right. I can't go down into the right anymore. I'm going to run out of space. My point would be somewhere like right about here, but I want to use the coordinate plane. I want to use those grid lines. So since I can't go down to the right, now I'm going to have to go up and to the left. So I have to switch both movements. Now I want to start back at the start value of the y-intercept. So now I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. I'm going to go left 2. 1, 2. Now, a quick visual check to make sure you did that right when you switch your directions. These should still line up in a straight line. So when I insert my line in there shouldn't be anything weird or bendy happening. It should kind of all line up correctly. So there's my line. Okay, I'll make it go across the coordinate plane. Let me pull it up all the way here. Okay, there is my line. Remember, if you're switching it, just turn that around and do the opposite. Okay, there's a quick intro to graphing lines. Hope this was helpful, and have a good one.